Welcome, this is the video lecture on isosceles and equilateral triangles. Here I want you to understand the characteristics of the isosceles triangle and the equilateral triangle. And to do that, you're going to need to be able to describe the angle and side relationships in an isosceles triangle. Then you need to be able to describe the difference between an isosceles triangle and an equilateral triangle. So I know those words might not make sense. That's why we have to define the vocab. We could classify triangles by their sides. A scalene triangle. A scalene triangle has no congruent sides, so none of the sides are equal. And isosceles have two congruent sides. That's why it's called isosceles, because there's two congruent sides. If there's all three equal sides, right, that's where the word equal comes from in its name, equilateral. Right, that's when it has three congruent sides. Next, you can classify the angles by the triangles by their angles. Okay, a acute triangle has three acute angles, and please understand that acute means it is less than 90 degrees. They can be right, which is one right angle, which is denoted by that box, which is 90 degrees. Obtuse means it is greater than 90 degrees. This is the big one right here, very big. And then you have an equilateral triangle, which means they're all the same. And for this to be possible, they're all 60s. Okay, an equilateral triangle is unique in the sense that we know the angles are automatically all 60s. Just some symbols for you to realize. The bar, the hash right here, just indicates that the two sides are the same. So the two sides are the same. Okay, and they denote this and this are the same. I just want to also tell you that you're going to have these angles here as well. These two angles are also going to be the same because these two angles tell you that these two sides are the same. Likewise, you have three congruent sides, which are denoted by these bars or these hashes, and you're also going to get the angles here. Means these angles are also congruent. So let's see how we do it now in Delta Math. In Delta Math, you are going to be given a problem asking to identify the triangle. In this case, we have all these different options. So we look, we saw that this is 414, 414. So these two are congruent. So it's an isosceles. So it's either isosceles acute, isosceles obtuse, or isosceles right. Do you see a 90 degrees? No, I don't see a 90 degrees. So it cannot be isosceles right. We can see if it's isosceles acute or isosceles obtuse. Looking at the angles, they're all less than 90. So we go isosceles acute. Again, isosceles come from these two sides being the same, 414 and 414. The acute comes from all the angles on the inside is less than 90. So submit my answer. See, I got it correct. Okay, two congruent sides, isosceles triangle, all angles are less than 90 degrees. Therefore, it's considered an isosceles acute. Let me do one more. Here, let's look at the angles. Sides. This side is 467, 5.6, 7.29. It has to be an scalene, right? Scalene acute or scalene obtuse. It cannot be isosceles because you have no congruent sides. I look at it now. Let's look at the angles. 40, 50, and 90. Ooh, look, I see a 90. Therefore, I know it has to be a right. So I can go to scalene right. The scalene comes from no congruent sides, and the right comes from that 90 degrees. Correct. Next, we can classify the triangles by the sides here. This is a simple problem. Give that a try. Please understand, to solve for the missing angle measurements, you will have to use your total sum of the inside of a triangle is equal to 180 degrees. All right. Number one, you set the equation up. 78 plus 31 plus angle 1 equals to 180. Combine like terms, then you get angle 1 is equal to 71. Okay, this is considered an acute scalene triangle because there's no congruent sides and the angles are less than 90. Number two, set up the equation, solve for it. Angle 1 equals to 110. This is considered an obtuse. The reason why it's considered obtuse is because this is greater than 90. It's considered scalene because none of the sides are the same. Number three, set up the equation, solve for the angle 1. I got angle 1 equals to 52. There's no congruent sides, but there is a 90 degree. So it's a right triangle. Okay? You could also write scalene if you want, scalene right triangle, but most of the time we consider just a right triangle. Number four, set up the equation. Once we solve for it, we know that delta angle 1 is equal to 60 degrees. We saw this unique because all the insides are the same at 60 degrees, so therefore the sides are also congruent. We consider this an equilateral triangle. Next, let's characterize an isosceles triangle by looking at its properties. Here we have an isosceles triangle, and this is spelled wrong. This should be isosceles. An isosceles triangle has two congruent angles and sides. Here, these angles are the same. So ABC, so this is angle ABC right here, is congruent to angle ACB down here. Likewise, this line AB has to be congruent to line AC as well. That is what is unique about an isosceles triangle. Two congruent sides, two congruent angles. Here's some vocab that you might see in your problems. The base angle here are when these are the same, they're referred as your base angles. The congruent sides are also are referred to the legs. So these are the legs. So here, these would be your legs here, right? Because again, it's like the legs that you have on you. They're both the same length. The tip here, think about this as the corner. This is like where your head is, right? And that's your arms and that's your legs. That's your head, right? So that's your vertex. So think about that. The base is right here. The base is considered what connects your two legs together. And that is also referred as your base angles here. So in short, leg. These two are congruent. Base angle. Okay? Makes up your triangle. On top is your vertex, which is your head. Here, this is a simple problem that asks us to solve for the x in the, not the equilateral, in the, this is an isosceles, okay? So, let's go about this, all right? Hold on, let me fix this. This is supposed to be a isosceles, isosceles triangle. Okay? All right. So, let's set this up. We could set up this equation because we know that an isosceles triangle has two congruent sides. And these two congruent sides are your two legs. So, the first leg is 4x plus 7. And that's going to be equal to the second leg of 6x minus 5. Okay, that's the reason why you're allowed to set up this equation. Here, there's no name for it, but here you can say these are your congruent legs, if you would like. Okay, and here on top you could say these are your congruent base angles. All right. Once you set up these two equations equal to each other, you can now solve. So you're going to subtract 4x to both sides because you want to remove the smallest variable first. Then you get 7 equals 2x minus 5 plus x plus 5 to both sides. You get 12 equals to 2x. Divide by 2, you get x equals to 6. Okay. What is the value of AB? If they ask you for the length itself, you have to just now plug it in. They just plug in the 6 in here because AB is referred to 4x plus 7. So plug in that 6 for x. 4 times 6 is 24 plus 7 is 31. There you go. That's how you solve for a value for x inside an isosceles triangle. All right. Now we're just going to do some delta math here to finish it up. It's properties of an isosceles triangle. Here you have a problem like this, but here we notice that we don't actually have the picture, so we have to draw it. So I brought this up into delta math, and now we have to draw the triangle. Okay, it says that angle J and angle I are congruent. So let me just draw the equilateral triangle here. Okay, I'm trying to draw it the best I can. Here is angle J, and this is angle I. And the fact that this is JI, so it goes from IJ, so K has to be above here. All right. It says the reason why I have to label these is because I cannot get the sides. So draw the triangle first, label your congruent base angles. Now it says KI. So KI equals to 14. So KI is down here. This is KI, right? This is equals to 14. Okay. Then it says IJ. So IJ is equal to 11. So notice what the congruent angles are. Notice that this angle J tells you about this side, which is equal to 14. Okay, this is also congruent. So if this side is 14, this side also has to be 14. Okay, so we write 14 here. Okay, there you go. Right, so that's how our picture was. To get the other side, we had to put 14. Okay, but it comes from us reading this. All right, so there you go. Those are all the problems that you need to know when it comes to identifying an isosceles triangle.